Hello class, so I wanted to talk about brightness and power. You're hopefully getting a lot of this from your circuit and actually building it, but you do need to know what factors affect brightness, how do you determine brightness in a circuit, and how do you explain your reasoning. So I highly recommend that you listen to this video because I will not write everything I am saying, so the audio should hopefully provide you a better explanation. Alright, first off, brightness is essentially the power. So how much power goes through it determines how bright it's going to be. Remember, power is current and voltage, so therefore brightness is going to be determined by how much current and voltage you have. So looking at these, hopefully you know by now that in general, parallel is brighter. Because it gets more volts. So remember, to explain this is each one, it's your loop rule. So each loop gets 9 volts, so each one of these gets 9 volts. These are only going to get 4.5 volts. However, something we hadn't talked about before is because of the way this circuit is set up, this one has more resistance. So in general, there's more resistance in series and parallel, which means because of this, so and I can quickly add these. If I add those, this is going to be a total of 10 ohms resistance. This is going to get you 1 over 5 plus 1 over 5, 2 over 5, 5 divided by 2, 2.5 ohms of resistance total in the circuit. Alright, and because of this, your current in this case is going to be much larger. So not only does each one have more volts, there's also more current. And there's more current. Alright, so remember, it takes both, and so now we're going to take a look at individual circuits and determine the total power and therefore brightness of each bulb. So really quickly, I want you to try to answer which bulbs are bright and which are dim. Try to answer this on your own and then come back for the answer. Alright, hopefully you know that this is your bright one and these two are equally dim, and let's explain. So we have some sort of total current that comes from here, and it does split up. So they are getting a little less current than, say, one individually might. However, there is less resistance here. There's only one resistor. That means more current will go this direction. And this one, whatever voltage we have, it gets the whole voltage. Each one of these only gets half the voltage. So this is definitely the brightest one. Alright, I'm looking at a different one. Alright, which one of these is the brightest? Go ahead, pause, take a second. Alright, now this one I think is a little trickier, but this is your bright one. These two are dim. Here's why. On this one, this is your loop rule. You have two loops. They're all, in fact, while there is a parallel circuit, these are all in series. So that says for any voltage drop, it has to hit both this one, my bright one, and it's going to hit one dim one. Even if this is my dim one over here, color code. So no matter what happens, I'm going to have to hit 2. But each one includes my bright one. So that means they're going to have to share voltage. So if this is, for example, is a 9 volt, they're the same resistance. They're all going to get 4.5 volts. However, if we talk about my current here, my current splits up. So they each essentially get half the current. However, this gets the whole current. So this gets 4.5 volts and the total current. Therefore, more power. Remember, our power this is equal to power. These two, they get less current, same voltage. So I get less of this stays equal, therefore my power must go down. Alright, let's try another one. Alright, so we can answer which one is bright or dim. Alright, and this one, honestly, they're all going to be pretty dim, depending on what kind of battery you have. However, you can see you have 3 loop rules. So that means here you have your total current, here you also have your total current, and here all of our currents get split up into 3 pieces. Because we have equal resistors, your bulbs do have equal resistance, it will just be a third of it. But again, you have to share your voltage by 3. But this again gets the total current, even has to share voltage. So again, there's a loop, so it shares the voltage. But they all do. They all have to share voltage. So in all things like this, if they all have to share voltage, but some of them get the total current, these 2 are essentially the brighter, and these 3 are going to be your dim. Alright, we will talk a little bit more about this on Monday and finish that conversation on Tuesday. So be ready for your quiz on Wednesday. Remember, you should always bring your battery, as well as you either should have Play-Doh, and again, I don't require you to buy this, or an old wooden pencil, like an actual wood pencil. Because remember, for some of you have seen us have this going on already in class, but you're going to cut them in half. I would not cut them until you get here in case you cut them the wrong way. Alright, hopefully this is informative, and I will see you on Monday.